sold for 3,100. Please note, it will have a life cycle of 10,000 units. And out of the 10,000 units, it is estimated that the first 9,000 units will be sold for 3,100 naira each. And then the product will enter the decline stage of its life cycle. It is difficult to forecast the selling price for the 1,000 units that will be sold during this stage. So that means out of 10,000, the first 9,000 units will be sold for 3,100. Cost. Labor will be paid at 300 naira per hour. Other variable costs will be 950 naira per hour. 950 naira per unit. Fixed cost over the life cycle of the product will be 2 million. The labor rate and other costs will not change throughout the product life cycle. Fixed cost over the life cycle of the product will be 2 million. The labor rate and other costs will not change throughout the product life cycle. Learning curve. The first batch of 100 units will take 1,500 labor hours to produce. There will be an 85% learning curve that will continue until 6,400 units have been produced. Any batch produced after this level will each take the same amount of time as the 64th batch. The batch size is constant at 100 units. And what do we mean by the batch size is constant at 100 units? A batch is what? 100 units. There will be an 85% learning curve that will continue until 6,400 units have been produced. Then 6,400 units is how many batch? 64. This a batch is one batch, so 64 batches. And so, required, A, calculate the cumulative average time per batch for the first 64 batches. Calculate the cumulative average time per batch for the first 64 batches. 2, the time taken for the 64th batch. 3, the average selling price of the final 1,000 units that will allow Daily Company Limited to earn a total profit of 2,500,000 from the product. Note, the learning index for an 85% learning curve is minus 0.2345. Ignore the time value of money. So that's where we stop. Question 7. The first one, which is A. The cumulative average time per batch for the first 64 batches. So what's the formula? What's the formula? Please give me the formula and time. We have many things to touch. I'm touching this question and one other question. So if you are not fast in your response to me, once it is time, we will not cover up what we need to cover. I believe we would have read the note. So the formula, give me the formula. I expect a response. That's what will make me to be sure that I'm carrying you along. If you're not responding, then you might not be able to understand everything I'm saying. Can you all hear me?
Yes, sir.
Okay, awaiting a response. The cumulative average time per batch for the first 64 batch. So how do we compute that? What's the formula based on what I gave you last week? is denoted as y equals ax raised to power b. I don't know if we actually went through all this. And what's y? From the note I gave you, what's y? What is a and what is x and what is b?
Y is cumulative average time per unit for all units made.
Cumulative average time per unit for all units made. And that is what we want to solve here. The question says cumulative average time per batch for the first 64 batches. So it's interpreting what y represents. And what is a?
A is the time for the first unit.
Time taken for the first unit.
For the first unit.
So from the question, let's look at the question. Learning curve. The first batch of 100 units will take what? 1,500 labor hours to produce. This first batch of 100 units, if you say a batch, the first batch of that is one batch is 100 units as we define here. So we take 1,500 labor hours to produce. So it is defining what? A, which is what? Time taken to produce the first unit. Do you get it? So here we have 1,500 hours times, the question says cumulative average time per batch for the first 64 batches. For the first 64 batches. So our x will be 64 and our b will be minus. Recall that the question says that what? Note, the learning index for an 85% learning curve is minus 0.2345. So raised to power minus 0.2345. Please give me your answer in 1 minute. If you don't respond in 1 minute, I'll move on.
One of the trouble you and I have. I couldn't just
565 point. Oh, so 566. 566.
566.
Yes.
Yes.
566 hours. I'm following what you give me. 2. So this is the cumulative average time per batch for the first 64 batch. The next one, the time taken for the 64th batch. If you observe the question I gave you last week, if the last question I said I gave was the time taken for the first 8, and for the first, is it 8 or for the first 9? And for the 9th batch, the last question. Check through your notes. Did he talk about the 9th batch? That we now have to do total time taken for the first 9 minus total time taken for the first 8. Was it that?
Yes.
All right. That what you see here, this II is a replica of that. The time taken for the 64th batch. So time taken for the 64th batch or cumulative average time per batch for the first 64th batch is actually different from time taken from the 64th. When we are talking about first 64, we are talking about 1 to 64. But when we are talking about the 64 batch, that is the exact position of that batch, which is the exact position of that batch, which is 64. So for us to get that, we'll say it is the cumulative, it is the total time taken for the first 64th batch minus total time taken minus the total time taken for the first 63 63rd batches. This batch. So what is the total time taken for the first 64 batch? Total time taken for the first 64 batch is equal to the cumulative average time for the first 64 batches times what? Times X. In essence, this is, what did we get as the cumulative average time for the first 64 batch? 566, Abi. Am I right?
Yes, sir.
So 566 hours times 64. Please calculate.
$36,224.
36,224. Is that right?
Yes, sir.
Now, since we have known this, let's go to the total time taken for the first 63rd batch, or first 63 batches. But before we can know total time taken for the first 63 batches, we need to know the cumulative average time for the first 63. So we say cumulative average time, or let me define it as Y63 will now be AX raised to power B, which is 1,500 hours times 63 raised to power minus 0.2345, if I'm right. We are calculate.
Six, 568.
568 hours. So total time taken for the first 63 will be 568 hours times 63. Give me your figure.
$35,767.
85.
35,767.
35,767 hours. So
Sorry, since they approximated 35,784.
35,784. So total time taken for the 64th batch will now be, what's TT64?
That's 56224. Oh, 36,224 hours.
Minus 35,784. Calculate.
$440.
400.
440.
40 hours. That's that. 3. The average selling price of the final 1,000 units that will allow Daily Company Limited to earn a total profit of 2,500,000 from the product. The average selling price of the final 1,000 units. From this, how many units were actually sold? Or how many units do they have in total, not sold?
6,000.
Yeah?
25.
No, 10,000. Please, you people should follow closely.
Okay, yes. You did not scroll up to the question part. Yes, 10,000 from the beginning.
10,000. Then how many was estimated to be sold?
Average selling price of 1,000.
9,000. 9,000 is estimated that the first 9,000 units will be sold for what? 3,100.
Sorry, I don't get. Where's 3,100 coming from? Okay.
It is sold for 3,100 naira each. And then the product will enter the decline stage of its life cycle. It is difficult to forecast the selling price for the 1,000 units that will be sold during this stage. So it is that 1,000 that I want to estimate now that we have here, the average selling price. So what will be the average selling price of this 1,000 units? So for us to estimate this, revenue or sales from 9,000 units. So simply say 9,000 times 3,100. Please multiply.
$27,900,000.
27,900,000. And we'll come here and say production cost of 10,000 units. And what make up the production cost? We have variable cost. From the question, what's our variable cost? From the question, what's our variable cost? Let's check through the question.
950. No, 950 naira per unit.
It's not only one cost there that is variable cost. Though.
We also have it.
We have labor. Hello, can you all hear me? What are the costs here
Yes.
that makes up the variable cost?
We have labor of 300 naira
Labor
per
of
hour.
300 naira per hour.
That's variable cost.
Then other variable cost of 950 per unit. What else? The
Okay. Variable cost, labor. So if labor is 300 naira per hour, if labor is 300 naira per hour,
number of
so what will
hours
be the
worked
total
is
labor cost?
15 times 300. The hour times
I mean for the 10,000 unit, oh. Production cost of 10,000 units split into variable cost and fixed cost. So under variable cost, we have labor cost. So what will be the labor cost for 10,000 units if labor will be paid at 300 naira per hour?
Should be the 10,000 units times the no rate times hour.
Now, if I may ask, what on what variable does learning and experience curve have impact on? What variable does it have impact on?
On labor.
On
On labor.
labor.
On labor. So that is where our major work is. Now, let me come here. From the question, how many units do they have? Or the product we have a life cycle of 10,000 units. How many units make a batch?
1,000 units. Abi?
100.
The first batch of 100 units take 1,500 labor hours to produce.
100 units.
There will be an 85% learning curve that will continue until 6,400 units are being produced. Any batch produced after this level will each take the same amount of time as the 64th batch. The batch size is constant at 100 units. Okay. So, and 100 units is equal to what? One batch. So out of this now, if 100 units is equal to one batch, 10,000 units will be how many batch?
$100 batches.
That's 100 batches.
100 batches. Now, from this place that they said that the 85% learning curve, we know what that 85% learning curve means, that the learning curve or the learning rate, which will continue to have impact because of what? Improve efficiency as they repeat the task, that learning curve will continue until 6,400 units have been produced. So after 6,400 units, any units produced, the learning curve will not have impact on it, as it will take the same amount of time as the 64th batch.